Hey, good morning, good afternoon, good evening, based on where you're at. And welcome to this live session. And we are going to talk about get started with Kubernetes today and get started with the pod. So let me first share my screen and we'll get started in a minute or so. All right, so here we go. Let's get started with basically an understanding of what are we doing here, why are we here, what is it that we are doing with the 50 days Kubernetes challenge. And we are on the mission 3 today. So, this week rather. So we've started this challenge with basically it's a 50 days Kubernetes challenge. And every week I'm sharing some sort of a challenge on one particular topic so far. And the first week we started with the art of writing Docker files. We also have this live sessions where we do some teaching part and learning. And this is a way to get some interaction and ask questions as well, right? So our first mission was to create the Docker files and build the container images. Then we looked at the Docker Compose last week, and I'd given you some challenges to write a Docker Compose file for the microservices application, the example voting application. It's a 5-tier microservices application, and you might have already completed those tasks given in the last week's challenge. This week, we get started with Kubernetes, and I'm going to show you a very quick way of setting up Kubernetes environment with 3 nodes. And it's a very interesting tool called as Kind. And then we will talk about the very fundamental unit of deployment in Kubernetes called as pod. I'll show you how to write a pod spec, how to design that pod basically, how does it look like in terms of the architecture, etc. And we will get started writing the pod spec in the form of a YAML. And I'm going to give you a AKMS formula there. AKMS is a very useful formula to understand any Kubernetes spec, really. And if you can take that out of this particular session, that is going to form the foundation of your Kubernetes mastery later. So we will talk about pods today, and I'll also show you how to create the pods, how to run the pods, how to troubleshoot the common issues with the pods, which is another important aspect of what you should know about in terms of the pods, etc. And then next mission is going to be about how do you make that application high available, scalable. That's where we'll talk about replications, replication controllers, namespaces, etc. Then we talk about the mission number 5 would be about Kubernetes services. That's how you connect one application with another. We will then go on to create a zero runtime deployment strategy with Kubernetes. We'll talk about data persistence. That's going to be in mission number 7, where you will learn about data persistence and the objects related to that in Kubernetes. With mission number 8, you would learn about the edge routing and ingress controllers. That's how you typically deploy the real world applications and make those available from the outside world. And then the last mission is going to be about how do you package your application, let's say a microservices application that we have taken. And as part of our exercises, we have taken this microservices application stack called as InstaVote. And it's a 5 services stack. And this is what you would end up deploying on Kubernetes with all those aspects, desirable aspects, including high availability, scalability, service discovery, load balancing, not auto scaling, but load balancing for sure. And all those, like data persistence in mind, and you learn about various controllers and so on, right? That's how you'd explore Kubernetes and you would start learning about it. Now, before we begin with today's session, let me also give you, a brief about how we would go about what is the duration of this challenge, because some of you may be new to this challenge and might have joined just this week. And in that case, I would highly recommend you go and check the course, the challenge course on the one you have access to already on the members.schoolofdevops.com, and go and look at the previous challenges and complete those, and then you get started with the next one. You can catch up with it if you spend a little bit amount of time there as well, and then you can still catch up with this same challenge, 50 days challenge, and complete it within the duration that we have set. There is going to be 7 weeks starting from November 23rd week. We've already started. We have 2 weeks past there. from there, and we're going to end it on approximately in the week of January 20th or around January 20th. And how do you get started with the challenge? Though some of you might be new, some of you might be attending this not on Zoom, but from the live streaming session on YouTube or Facebook Live. And for you, you can get started with the challenge by signing up to devopsclub.co and /Kubernetes. So it's devopsclub.co. Very easy to remember, devopsclub.co/Kubernetes. And there you can fill up the form and get started with the challenge. You'll have an access to a challenge. You'll learn how do you get to the Zoom call from the next week as well. And what we have open for all is the weekly email challenges, plus the live coaching. It's not just email challenges. You have access to the course where I'm uploading the recordings, uploading the challenges and the documents and the knowledge that you would need in order to complete that week's challenge. And we are doing these live coaching sessions on Thursdays, typically over Zoom, and it is being streamed to multiple platforms as well. And if you are a paid member of our community, DevOps Club, on schoolofdevops.com, you also have access to the course, which could help you take a structured approach and like a shortest way to get to master Kubernetes, etc. Right? So that's something you can consider always. And if you have questions, especially if you are on Zoom call, you can ask me questions directly. If you are not on Zoom call, I would recommend you go to devopsclub.co and ask now. And that will take you to a form and you can post your questions. I will take those questions either towards the end of the session based on the time, or I would answer them later through the School of DevOps channel. So you can also subscribe to the YouTube channel, which is on youtube.com/c and then School of DevOps. Right, so you can also have subscribed to the channel, and through the channel I would be updating the content, and I'll probably answer the questions if there are any which need a separate answer later. So this week's challenge is going to be about Kubernetes. We get started with Kubernetes, and we are going to get started with the concept of pods, right? But before we do that, the folks on the Zoom call, are there any questions, anything from the previous weeks, any questions or anything that you want me to address before we get started? All right, let's also try to make it as interactive as possible. Yes, go ahead, please.
Gaurav, I have not attended last two sessions. This is my first session. So will I be able to catch up what you are being explaining today?
Yes, because this is an independent. We start with we start with a sort of an not completely independent, but it's Kubernetes we start with. So you can get started with Kubernetes and you can continue with that. But it's important to have some understanding of how to build container images at some point of time, because Docker is like a foundation for Kubernetes to understand it completely. But it doesn't mean that not knowing Docker would stop you from learning Kubernetes at this point of time. Okay, of course, there'll be some sort of a disconnect that you may feel that, how do the containers work, or some basic commands like how do you get inside a container or a pod, and what is the difference between a pod and a container at a fundamental level as well. So you may get confused a little bit here and there. So it is okay to get started with Kubernetes, but definitely start catching up on Docker as well, especially the fundamental parts of Docker about what are containers essentially, how do you run containers, how do you operate containers, what is the Docker exec command, Docker logs command. So start getting familiar with that on the side, but do get started with Kubernetes as well, because I'm pretty sure that at this point of time, you shall be able to catch up on Docker. If you spend a few hours on Docker, you should be able to do that as well. So you get started with Kubernetes, but look at the challenge, look at the essential topics, knowledge part, and go complete those sections. If you're part of a membership program, you can get access to the course as well, or you can independently do that on your own.
Sure, Gaurav. Thank you so much.
Sure. All right. I think there was also a suggestion about, I'm giving you the challenges, but not a way to verify or validate whether you have completed and what you have done is correct or not. So I'm thinking about those options there. Either we'll create some sort of a checking mechanism, some script to check, or maybe provide you a solution later. But I want you to actually go through it completely on your own. That's why I'm not giving you the solutions at this point of time as part of the challenges course. But let's think about what could be the best way to go about, providing the solutions or having an ability to check whether you have done the right thing or not. Right. So we will think about it. Anything else, folks? Anything else before we get started with Kubernetes today?
Yeah, hi, Gaurav.
Yes.
Nothing really.
Yeah, let's take one question at a time. So I think it was Praveen.
Yeah, Gaurav.
Yes.
I have one query regarding Kubernetes.
Sure.
So through our challenge, will you going to explain liveness, readiness, and the serverless concept?
Serverless, no. Liveness, readiness checks. You're talking about the probes, right?
Yeah.
We'll take it up. We'll take it up at some point of time based on how much time we have. I'll note it. I'll make a note of it, and we'll definitely talk about it for sure.
And also with the service mesh concept.
No, we're focusing on fundamentals of Kubernetes. We are not even completing all the topics of Kubernetes related. There's a lot to cover in Kubernetes. So since we have a limited time of, let's say 7 weeks, we are not going to go and talk about service mesh and confuse you even further. So the focus is going to be to build the foundation on Kubernetes. But I do have a separate course. If you are interested in exploring service mesh, I have a course on, let's say, Istio, which you can explore.
Okay.
Part of the membership, gold membership as well.
Sure. Yeah, thank you. I understand.
We will not be able to do that. So neither serverless nor service mesh, but probes are like essentials of pods and configuration stuff. So that we will take up, no problems.
Okay, Gaurav. Thank you.
All right, perfect. Thank you, Praveen. Anthony had a question, I believe. Anthony, go ahead, please.
No, I didn't have any questions to ask. I just wanted to comment on the project last week. It was actually great. We had to do like some troubleshooting on the DB side to actually make it connect, because when I started up with trying to like build the container with Docker Compose and all, so I later got to find out that I was having issues with the DB not coming up. So I had to go down into configuration file, use the environment variables and also the password and all to actually make it connect, and it worked fine.
Sure. So are you talking about the DB environment variable for the DB where you need to set the password?
Yeah.
Yeah, that's right. So I'm really glad that you could figure that out, because it fails otherwise when you start launching the DB. And I think I will take it up the same issue today, because as part of the pods as well, we are launching the DB, the same image, Postgres as a and at that time, I'll address this particular issue. But I'm really glad that you could solve it with the environment variable, and you could find that on your own.
Thank you.
Awesome. I think we'll probably have a way to submit the code and maybe audit one or two solutions, so that everybody understands what this means as well. Right. So, or we'll have a separate session to do that. I'm just thinking, if we try to figure out how to go about, giving you a way to, complete the challenge and also check in. All right. That sounds great, Anthony. Anything else from anyone in the Zoom room? All right. So those of you who are on the streaming platforms like YouTube, you can send in the questions using this link, devopsclub.co/asknow. It's devopsclub.co/asknow, right? If you're on Zoom, you can stop me anytime and ask your questions as well. I'm just going to take one moment to see if I can connect my iPad, which I typically use to explain things. If else, we'll continue anyways. So give me one quick moment and then we'll get started. All right, I'm just trying to connect my iPad. You might have noticed that I'm not in my office typically. So this is a co-working space I'm working out of. So I'm just trying to see if I can connect the iPad to the computer. If not, I'll get started anyways, explaining the concept from the computer directly. All right. Seems like I'm out of luck today. All right, let's get started. We'll talk about a few things. I'm going to have you as part of, a prerequisite. I'm going to have you build some, based on Kubernetes on your own. Since we have, short amount of time during these sessions, we want to cover only the parts which are more relevant towards that topic. Today it's about pods. But before that, it's important to know how to create a Kubernetes cluster and validate that. And I'm going to show you a tool to actually do so. But before that, before we even get started with that, I want to explain to you the architecture of Kubernetes. What is Kubernetes and how does it really work? And what is the architecture of Kubernetes really, right? So Kubernetes, why do you need it when you have Docker, for example, is because couple of reasons or a couple of things that Docker can do, right? Docker is a great way to provide you with image format. So Docker gives you that standardized packaging format called as container image or Docker image. And then it gives you a way to run that in an isolated environment. That is what we call as a container. Now, you can use Docker or even Docker Compose to launch those containers on one host, but it cannot cross the boundary of that one host, right? Because when you want to do it in a production-like environment, you want to launch containers at scale. You want to launch probably hundreds and thousands of containers on probably hundreds of hosts. And in that scenario, Docker alone will not be sufficient, right? And that's a very realistic scenario where you have to create, hundreds of containers on probably tens of nodes or 50 different nodes, or, even in some cases, thousands of nodes as well, right? So how do you go about it is where Kubernetes comes in, and Kubernetes gives you a way to launch your, basically what you do with Kubernetes is, let me bring up my presentation. Slides instead now. So what you essentially want to do with Kubernetes is, let's say you want to deploy a 5-tier microservices application stack on a bunch of servers that you have. Let's say you have 4 servers, or it could be 40 or 400. So what you essentially do is you take those servers and convert it into a cluster. So to you, it looks like one single entity, one single large cluster. And, beneath that, you have your all computers, all your nodes to run your containers on, right? So those form the pool of servers which are part of that Kubernetes environment. And you can start with 4 and then add 40. And when you want to scale up, you can go and add 400 to up to 5,000 nodes in one cluster. But when you look at that cluster and when you interact with it, it is just one single entity that you're talking to, right? And then you use a client such as kubectl, 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 and talk to the Kubernetes environment and start launching all your your workloads on top of that environment, right? And there you can partition by using namespaces. We'll talk about the concept of namespaces in the coming week. But right now, I just want to focus on the concept of pods, right? So basically, Kubernetes gives you a way to take all the nodes and convert it into a cluster, and you talk to that cluster, and underneath that you have a pool of servers. Now, if you look at the architecture, we're talking about multiple nodes, right? And when you talk about Kubernetes architecture, just like Docker, it is a client server environment, right? And the server side, it's much more complex than Docker, because with Docker, you just have Docker daemon. With Kubernetes, you have a bunch of components out there, starting with API server. And when you use kubectl, kubectl, or anything else to talk to Kubernetes environment, you're talking to the API server, essentially. And API server then coordinates with all the other components which sit inside that Kubernetes environment. And what are the other components apart from API server? Let's look at that. The second component is the scheduler. And scheduler, the job of the scheduler is quite simple, straightforward. It is to decide what runs where, because we are talking about running containers on a bunch of servers that we have. So which server runs which container, or when you launch a bunch, workloads, maybe 20 different containers you want to launch on those. How do you decide which container runs on which node, etc.? That is basically determined with by the scheduler. So a simple job, but it is quite sophisticated, but because it has to know about the resource allocation on the host, what are the resource constraints, how much resources do your workloads require, and based on that, it will try to map it to the right server. And that is the job of the scheduler. So the second component is the scheduler apart from API server. The third component is the controller manager. So when we talk about Kubernetes, which provides us with high availability, scalability, ability to roll out new versions of the application without downtime, and so many other features which sound very interesting, all of those are provided, or most of those are provided by the controller managers. And controller manager is one binary, but it has many different types of controllers built into it for different types of workloads. For example, if you want to run stateless applications, typically your web application, front end, microservices, and so on, you could use a controller called as deployment. And then for, if you want to run some agents on every node, like logging agents, monitoring agents, etc., you have daemon sets. That's a second controller. For stateful applications like databases, you have a controller called as stateful set. You have jobs and cron jobs for one-off ad hoc jobs and scheduled jobs. So you have different controllers which are then built into that one single binary, which becomes part of the Kubernetes environment. That is in the form of the controller manager. So you have scheduler, API server, controller manager. And finally, you have a component called as etcd. I'll not go in depth into etcd, but think of etcd as a configuration database. So everything that you create in Kubernetes, let's say you created a deployment, an entry is made in etcd, and who talks to etcd? It's the API server. And etcd is very important because if you talk about providing high availability to the Kubernetes cluster environment itself, you have to first think about etcd and making it high available. Taking backups is mostly about taking etcd backups, right? So for Kubernetes environment, so etcd is a data store which stores all the information about everything that you have launched in that Kubernetes environment at any given point of time. So that's the etcd part. So that's the fourth component. And then you have something which runs on every node. And what are the things that run on every node? Every node that participates in the cluster, for example, runs these three things. First is kubelet. Kubelet is like an agent sitting on the node, making sure that whatever Kubernetes wants to run is communicated to the node, and it is actually launched in the form of containers. And it also does the health checks. So there was a question by Praveen about how do we do the probes, right? So the liveness checks and liveness probe and readiness probe. There are two types of health checks. Those are done by the kubelet itself, right? So when you talk to the API server, when you call, let's say, ask to run some workloads, you are going to use some utility like kubectl, and you are going to ask API server to run something. The API server will call the scheduler, as in it puts that in the scheduling queue. Scheduler comes in, decides or picks up the node, and then the kubelet on that node is informed about it. And it is the kubelet's job to talk to the actual runtime. And runtime could have been Docker earlier. And now it is more about you have runtimes like Cryo and Containerd, because Docker has been, Kubernetes has stopped supporting Docker as such. And I have made a video about that specifically, which is, which is all available on my channel as well. And the entire story about why Kubernetes stopped supporting Docker and how does it impact your workflow? Because if you look at your development workflow, it still remains with Docker. And then whatever the image that you create is a image which is in a standard format called as OCI. Everybody agrees and everybody knows and everybody can run that image. So you can take that image and run it with any other runtime. And Kubernetes has its own way of connecting to runtime called as CRI, Container Runtime Interface. So you should watch that video to understand that story and what is the impact of on your work, etc. But it's basically the kubelet which Kubernetes cares about. And Kubernetes thinks that kubelet is the one which is running the container. So it doesn't matter whether there's Docker, whether there's CRI-O, whether there's containerd. Kubernetes overall has no, I mean, as a whole, if you look at it from the high level things, Kubernetes and the control plane doesn't. Control plane is the master side or server side component. It doesn't care about who's running the container. It only bothers about kubelet reporting to it what is happening. So for it, kubelet is the one which is running the containers. Kubelet is the one which also does the health checks, and that's where the liveness probes and readiness probes and all those components, all those things come in, right? So that's about how the work, how it actually how you run the containers, etc. And as far as you can see that kubelet is the one which reports, it interfaces with the runtimes, and there are a couple more components in addition to kubelet on every node. Of course, the runtime, CRI-O, containerd, or anything which is CRI compliant. CRI is the language Kubernetes uses to talk to the container runtime. Any runtime which understands that language can talk to Kubernetes, essentially. That is what it means. And then there is a component called as Proxy. Proxy is essentially responsible for the higher level networking, as in service discovery, load balancing. We're going to have a separate mission and a session on that next week, where we'll dive deeper into the networking part of Kubernetes, where you'll understand this through and through. And that's a very interesting concept to know about, right? So the Kubernetes service networking, load balancing, how do you connect the application within the Kubernetes environment, etc. So all of that will come in future. We will talk about it, but this is how the Kubernetes architecture looks like at a very high level, right? So you have the control plane. It used to be called as a master node, but now it is called as a control plane. In general, in the world of technology, the concept of master slave is going away, which is good. And it is being replaced with, now in Kubernetes world, it is control plane and the nodes. In Jenkins world, it used to be master slaves. Now it is it is basically the server and the nodes. So you have this nomenclature which is changing in the world of technology, and that's been the trend for the last 2 years. So if you have noticed already, so that's the architecture of Kubernetes. I'm going to show you how to create a Kubernetes environment in, let's say, 5 minutes or less, and it's going to be probably the quickest way to do so as well. So any questions on the architecture of Kubernetes? All right. Now I'll demonstrate to you how you could set up a Kubernetes environment very quickly using a utility called as kind. Kind stands for Kubernetes inside Docker. And what does that mean is basically we would use Docker as nodes. Typically, your nodes are your virtual machines or your cloud servers. But in this case, we would use containers as nodes itself, right? And that is where kind as a software comes in. And I've already installed kind on the server. So basically I have taken the server. This is my VM, and I have Docker running on it. In fact, I'll clean up everything on this node right now. So Docker PS, I'm hoping you're able to see my screen. In case if you're not, give me a feedback. So Docker PS, I'm just gonna use -q. So to list all, get the container IDs of all the containers running here, and then feed it to Docker rm-f. And that cleans up my environment. Basically, that's what I wanted. I wanted to start with a clean state. So I have Docker environment here. This is the first prerequisite for the kind to work. Second prerequisite is the kind itself, which is installed. Now, I will be sharing and uploading this document on the challenge portal. And this explains to you how to set up that environment, how to set up kind itself. So if you go to this document, it has the instructions to install kind. Now, I won't show you because it's very straightforward. If you just go to the quick start, you have to find out or choose how you want to install kind with the package manager, with the release binaries and so on. And if you're on Mac and you're installing kind directly, for example, you can use brew or similar If you're on Linux, you can directly install it using the release binaries, etc. And this is what I have used install kind on this Linux server. So this is the Linux server. This is the Linux environment. Let me show you that. It's I believe it's a Ubuntu environment, and I have Docker running on it. I have installed kind here, and I have also installed kubectl, which is the Kubernetes client. Kubectl or kube control is how you talk to the Kubernetes cluster or the Kubernetes control plane, the API server itself. Okay. All right. I have also zoomed it so that it is, it's a better visibility for you. All right. So are you able to see my screen now? I think there seems to be some problem, Dinesh.
Yeah, hi, Gaurav. There's on the side. Sometimes I'm not able to see. I request you to zoom in the screen.
I've already zoomed in. I think if I zoom in even further, it will be almost the output will be scrambled on multiple lines. So this is probably ideal in terms of showing you visibility plus showing you the commands as well.
Thanks, yeah, now something visible.
All right. Okay, we'll continue. So I have installed kind, I have installed kubectl, and I have Docker already there. So what I'm going to do next is very simple. That's why I said it's a very straightforward, simple way of creating a multi-node environment. Of course, you can use Docker desktop to check one box and set up a Kubernetes environment, but it's just a one node kind of environment, which I don't recommend a lot when you want to really learn about it, because you don't really see how networking happens. And we're talking about an orchestration engine where we have multiple nodes, right? So if you don't have multiple nodes, then it's very limited in, it's okay for development once you have a hang of it. But if you're getting started and if you want to understand Kubernetes, this is probably the simplest way to get a multi-node kind of environment. And how do you do that is you just clone the code. So I'm sharing a code. Basically, I've created some configuration for setting up 3 nodes basically here, and you will find it here. So if I show you the code, this is my Kubernetes repository that I use for my trainings as well. And you will find a configuration for 3 nodes. It's a cluster with 3 nodes. There's one control plane, some port mapping configuration. I'll explain to you a little later what this is for. There is a worker node. There are 2 worker nodes or 2 nodes and 1 control plane, as you can call it here. So the configuration of how to launch it, what configuration is given here. And all you have to do is clone this, which is what I have done here. Go to the directory where this file is, the config file that I just showed you. The same file is here with 2 worker nodes and the control plane. And all you have to do is say kind create cluster -config, and that's it. So kind create cluster -config and the file name, and it reads that file. It would download an image. This is the one which will take some time. So if you're doing it on your local workstation, expect it to take about 5 minutes or so. And then it would go ahead and basically launch the cluster. Okay, just starting the recording now. All right, so what I'm demonstrating right now is 3-node cluster with kind. The document will be shared with you, and it would be uploaded to the challenge portal. And what I'm doing right now is I've cloned this code, gone to this directory. This has a configuration to create 3 nodes cluster. And that is what I've launched with this command kind create cluster -config and the YAML file. And it has pulled the image. It has prepared the nodes. It is writing the configuration. It's starting the control plane, which is the Kubernetes master or the server-side component, the control plane part. CNI is the networking, the underlying lower level networking, and storage classes for the persistent storage. And then it has created 2 nodes and connected that to the control plane as well. Now it's all set up. I will just validate by running kubectl get nodes. This is my first validation command. You see, it's not yet completely ready, and that's all right. It takes a few minutes because it has to, start the applications. It has to connect the nodes together. It has to start the networking services. That's an important component. And only then all the nodes will be in a ready state. So it will take a minute or two. Right, I was watching using this watch command. Watch is a very useful utility, by the way, that I use extensively. I was trying to watch the output of this get nodes command right here. All right, there's a question from Revan about do they use kind to provision cluster in production? Absolutely not. This is just a sort of a lab environment, simulated environment. It is not a real environment that you use in production. The reason for that is in reality, your nodes are some VMs, some physical servers, and you use a tool like kubeadm to set up the cluster. Right. So if you are part of my course LFD 254 or the Kubernetes Mastery, I typically take that kubeadm approach to create the clusters. But I have discovered this recently. And if you want to get started, this is a quick way of doing it with least amount of resources, because otherwise the first thing that you have to do is set up 2 or 3 VMs. And that itself takes up resources and time both. And this is basically running on one VM. All of this entire environment is running out of one VM, right? So this is not even VMware. VMware is like, with VMware, you can create one VM, and within that VM, you can create this multi-node environment. I'll visualize it and I'll realize what we have created here. So the next thing that I'm setting up is a visualizer. Again, this is something that I use extensively in my trainings because it's a very interesting tool. It's not a Kubernetes dashboard or anything such like that. It's not an official tool, but it's a open source tool that I found somewhere. And it's fantastic to understand and visualize what's going on with this cluster. So let me show you what I have created. I have just set it up. I mean, you just have to copy and paste the command. And in Kubernetes, it works. Everything is containerized, so it is expected to work. And you will see visualizers such as this. Let me show you that here. This is my IP address, and I'm going to a browser. And here I would go to this port 32,000, and I do have that visualizer. Let me scale it up a little bit. Now, what do I have? What do we see here? What we see is a node cluster, just like how I see it here with kubectl get nodes. What are my nodes? I have a control plane, kind worker 2. You see the same nodes here: kind control plane, kind worker 2. So this big box is my cluster. These 3 boxes are the nodes, and the small green boxes are the actual pods. You can think of it as containers for now, but these are called as pods in the world of Kubernetes. And I could list all of those using another command such as get pods -a. Now, okay, this is why I didn't want to zoom in too much, because then you lose the output to the next line. All right, so you can see these are the pods. So I can hover over these boxes, and you'll see the same names out here as well. Controller manager, the API server, the network, etcd. You see the same thing here as well, right? So etcd, there's a controller manager, there's an API server, there's a scheduler. Everything that I showed you on the architectural page. Along with that, you have kubeproxy, which runs on every node. There's some storage configuration. There's some networking plugin installed here. There's a DNS server for service discovery, DNS-based service discovery. And then finally, there's a visualizer. The visualizer is nothing but this tool itself that you see here has been deployed as a container as well. So this is another validation command that I typically use. So kubectl get nodes is the first one. And when I see the nodes listed and ready, I know that my cluster is up. And then when I run,
is it this every service is one pod?
Every no, basically every entry here is a pod, right? Every line item is a pod, And for some services, for example, Proxy, there are multiple pods because you have 3 nodes. So there's 1 pod running on each node, right? So each entry is a pod, and some have, you see 3 items for some services or some components because it has to run on every node, etc. Right? But everything else, like this is 1 pod, this is one pod, and so on.
Okay. And the IP address which you have used to in browser, the IP address of the cluster.
This is the IP address of the node. It could be, so this is a very special setup. So there's only 1 node as such, as in there's only 1 VM that I have, right? And I can only access it using that 1 VM, right? But within that VM, I have multiple containers running. So in reality though, let's imagine I had 3 VMs running as 3 nodes. So which IP address would I have used here? In this case, I could have used any node's IP address because this is the service of type node port. Again, we will explore this service on next week, the service types, but this is a service of type node port, which means I can go to any node and access it there. It's like Docker port mapping, but it works on any node. I'll show you the magic of that when we get there, get to the service part. It's a service called as Kubernetes View that you see here. It is available on 32,000 port. On which node? On any node. That's why it is called as a node port. So don't worry about it right now. We'll look at it when the time comes.
Sure.
Yeah. So for now, just think of it as this is a visualized version of this Kubernetes environment, which is easy to understand as well, because when I deploy something, let's say a pod, you will actually see it right here, right? And everything else that I do, like launching pods, scaling it up, we will actually come back to this visualizer often and see how things work in Kubernetes. So it's a very useful learning aid for us. Moving on, let's start deploying pods, and we're talking about pods, and I just mentioned about each of this is a pod, and we're listing pods as well, right? So now where are the containers then? Because we're talking about container orchestration. So where are the containers? What is a pod? What is the difference between a pod and a container? Let's start with that. That's a good starting point when we talk about pods. Now, why the name pod also? There's a very interesting story. I have narrated that. I think it's all available on YouTube channel, as well as my course, of course, LFD 254. So if you are part of the silver membership, I would highly recommend that, because then you get access to all these resources, including the story of Kubernetes, which is important to understand. You'll know why, because the whole name pod, where it comes from is in that story, because it is originated from, does anyone know what is Kubernetes inspired from? Yep. And okay, so there were 3 developers from this particular company, which is very popular. Which is that company? And
Google.
Google, exactly. So 3 developers from Google created Kubernetes. So of course, Kubernetes is inspired by something that Google used to run their containers with. What is the name of that something? The orchestration engine that Google created originally. No, not Docker. It's a 4-letter word, starts with B. I've given you enough.
Borg.
Borg, exactly. So Kubernetes was originated from Borg. Borg was what Google created originally in 2003, that is 2003 and 4, when Google moved to the world of containers. That is 10 years before Docker was created. Okay, that's very interesting. And then even the concept of pod comes from there. That's why I say it's very important to know that, because Borg has a similar concept. And when pods were created, it followed the same approach, right? So, and why was it created? What is a pod? Let's talk about that very briefly. I'm going to be very brief with this concept of pods, right? So you typically with Docker, you take an application, you create an image, and you run it as a container. Right? So one application, one image, one container. There is 1:1 mapping. And container is supposed to run only one application typically. Why? Because it attaches to the application, it monitors that application, it can restart that application, and container is nothing but an application running in a contained environment. And it's not supposed to, it is not meant, even though you can, it is not meant to run more than one applications either. So that's why I say one application, one container, one image, one container. That's typically the mapping that you see with Docker. Now, sometimes you have to run more than one applications together. And case in point, I really miss my iPad because I typically explain it step by step here, but let's see if I can do that. It's something here. The PDF versions of my slides, maybe. All right. Yeah. So let's take a use case here. Let's say you want to run MongoDB, and then that basically there's a monitoring system in place as well, right? It is not in this picture, but let's say there is Prometheus monitoring system. And when you have Prometheus, you would run something called as the exporter along with MongoDB. So Prometheus has this concept of exporters. So you want to monitor Mongo, you add a Mongo exporter service to Mongo, which will collect the metrics from Mongo and send it to Prometheus basically. And same with MySQL and all, like there's so many applications that Prometheus integrates very well with, and it can fetch like hundreds and hundreds of metrics from that application. So this is like a specialized exporter service that you launch and run on the machine on which Mongo is running. Now, in this case, wherever there is the prerequisite here is, and the problem that we are trying to solve here is, wherever MongoDB is running, you have to run the exporter on the same host. And how can you achieve that is you can possibly take multiple approaches here. One approach could be you have Mongo and exporter put in one image, but I just mentioned to you that Docker or containers are created to run one application typically. And if you run more than one application, let's say if you run Mongo and exporter within the same container, what could happen? Why this is an anti-pattern? Why you should not do this? Anyone? Anything that comes to your mind? Ports could be a problem. Possible. In this case, it wouldn't be. But there still are a few other additional problems. If you run, let's say, MongoDB and exporter on the same container, there are other problems. And that would include, let's say, yeah, go ahead.
Logs, how would we differentiate between the two logs? Mongo and exporter, if they're running on the same container.
Exactly. In fact, getting the logs itself will be a challenge because your Docker daemon or container daemon runtime will typically attach to one primary application, only one. And then it is ignoring the second application like exporter. For example, in this case, it will attach to MongoDB. It will know about MongoDB. It can restart MongoDB if needed when it crashes, but exporter is ignored. It doesn't watch the exporter. It doesn't even know how to get the logs from the exporter and so on. So that application is ignored, right? So logs, managing the lifecycle of the application itself, all of that is not properly done. Second problem could be, you're sharing the resources between Mongo and exporter. If exporter has a problem, let's say it has a memory leak, and it can affect the performance of Mongo, which is your primary application, and it's not supposed to, get affected because of the sidecar or a auxiliary application. And that is where this problem also, that is the reason why you want to run them in their own containers, separate containers. And that way your each of the application is handled separately, cleanly, and the resource management also is independently done by by your runtime. And how do you ensure that happens is where the concept of pod comes in. Now, what is the concept of pod and how does it really work? Pod is basically a logical entity. It's not a physical thing. You want to run more than one containers together, right? So the problem that we're trying to solve is we want to run two applications on one host, right? and we want to run them in their own containers. So we need to create those own containers. Sure. Okay. So we'll do that, but then we'll wrap it up, take those containers and wrap it up into a logical entity called as a pod. That is where the pod comes in, the name of pod. So all the P's in the same pod travel together. That's probably the inspiration behind the name pod, right? And pod was named, the name pod was given just a night before it was released to the world in 2015, Kubernetes as a software, right? Because in Google, it's called something else. It's called as alloc. But in Kubernetes, they named it as a pod. All the P's in the same pod, all the containers in the same pod travel together, as in on the same host. They're launched on the same host. They're part of the same unit. So the unit of deployment is not just a container, but it's more like a wrapper, a logical thing on top of that, which is called as a pod. And it is made up of multiple containers, one or more containers. A lot of times it's just one container. How do you know how many containers are there? You can see this list of pods. So what you can display is not a container, but a pod, right? You cannot launch a container independently. You can launch it only within a pod. And that's what you see running here. And you see these many pods running, and how many containers each of this is running? Typically one. So you see that ready. And if it says 2 out of 2 or 1 out of 2 or whatever / whatever is how many containers it is supposed to run in that pod. It could be 1 or it could be more than that as well, right? But if it is more than that, what happens is each of the application is running in its own container. And then it is all the game of namespaces. We're talking about kernel namespaces now. And that's what makes up the containers, right? Containers are nothing but a bunch of namespaces and your application running within those namespaces, etc. And in this case, each of the container has its own root file system, as in its own image, its own process IDs, and processes are separate, but it shares certain namespaces, right? And those namespaces are like networks and host names, and it can also share the volumes later. But basically, there are certain common namespaces. So basically, how these namespaces are shared is it's a Docker, it's a container thing, basically. It's not even a Kubernetes. Kubernetes leverages that in the pod, but you can also create containers like 3 containers with common namespaces, common network namespaces. I'll just show you an example of that. And this is also where the typically sidecar concept comes in. So you have one main application, in this case, Nginx. There's a file sharing service, like file update service, that is auxiliary service here. In case of Mongo and Exporter, Mongo is your primary application, Exporter is your sidecar. So anything which in auxiliary, which acts like auxiliary service, apart from the main app, is a sidecar, right? So that's the concept. And then each of this application runs in its own container, but there are certain common namespaces. For example, the host name is common. Host name is given to the pod. The IP address is given to the pod. Let me show you that. So the IP address is given to the pod, not to an individual container. And containers can share the namespaces. And this is a container concept in general. I'll show you that. So Docker run -idt. I'll give it a name. I'll call a container called as infra container. So in pod, there is a hidden container called as infra container. I'm creating a similar thing here, simulating that here. So I'm creating it with Alpine, and I launched the infra container, which you can see here. Now, if I inspect that infra container with Docker, it has an IP address of 172.17.0.2. Remember that. 172.17.0.2. That's the IP address of infra container. Now I'm launching 2 more containers. This time I'll do something interesting. So, okay, I'm launching a container called as app. But what I'm doing interesting here is I'll say network wise, connect to a container peer. This is called the peer networking. Connect to a container called as infra. So I'm launching app with the same image. It could be a different image as well. And then I'm launching another container called as sidecar. Again, with the same network configuration, meaning both app and infra, app and sidecar are going to connect to infra container for the network configuration. Let me show you that. When I inspect app, there is no network at all. no network configuration of its own. Sidecar, same, no network configuration of its own. But notice this. If I go inside the app container, it has an IP address. Whose IP address is it? 17.0.2. You already have guessed it. And sidecar as well. 17.0.2. Everyone's IP is same. How is that possible? This is possible because Docker containers allow you to share the namespaces. And that's exactly what happens within the pod as well. There is something called as the infra container, which is created. Let me see if I can have a visualization of that. Yeah.
Gaurav. So,
Yes.
yeah, basically what you have done is you have basically created 3 containers that share the same namespace, but every other component is isolated from each other.
Exactly. So if you see this diagram, basically there's an infra container with its own it could be with its own process, with its own image as well. And then you can create an app container with its own process. There'll be process which is separated. The image will be different, but network wise, they'll share the same IP address, same network configuration, same network namespace actually, right? And this is why I said ports would not be a problem, because anyways within a pod, even if you're running an app and sidecar, you're sharing the same IP, same host network wise. So your port have to be different anyways, right? So that's how it works basically. So there is a hidden container beyond your applications and application containers, and it's called as an infra container. You can typically, if you have a container runtime, you can identify that container running a paused process, right? So if you just list your containers or could manage to do that, you will find the infra container also running in addition to the applications and the sidecars if you have some, right? So now why not do this, right? So another question you could have when I talk about pods is pod is a logical grouping of containers, right? One or more containers. When you have to run more containers than one, it makes sense to create the pod, sure. But what about if I have to run one container most of the time? Can I run it outside? Well, if you have that question, Google also thought so, but this is the information from their white paper published related to the origin of Kubernetes and Borg and Omega, because Google started with Borg. Later on, they created Omega, and then Kubernetes was inspired based on both. Now, here is the important, line from that document. So they say that Borg also allows the top level application containers to run outside of allocs. Now, again, what are allocs? Allocs is the name of pod. What we call as pod in Kubernetes is what called as allocs in the world of Borg. And what they're trying to say is we allow containers to run outside of allocs. But what is important is the next line, or the next part of the line. This has been the source of much inconvenience. So Kubernetes regularizes things and always runs an application container inside a top level pod, even if the pod contains a single container. This is the most important part. So they tried doing that and they found so many issues with it, and it was so inconvenient. They decided to regularize things and standardize it. So there's only one way in Kubernetes, that is a pod. You have one container, run it within a pod. You have more than one, happy to run it within the pod. No problem. So that's how it works in Kubernetes. So there's a new concept of pods, and that's good because then you don't have to worry about, what are the pods and what are the containers and stuff like that. And it could be an independent set. So you don't have to bother about that at all in Kubernetes. It's just pods and pods alone. And that brings us to the how do you create the pods concept next, right? And that's when I'm going to show you the AKMS formula. And that's a very important formula to understand anything in Kubernetes, any object in Kubernetes typically. And how do you write it in Kubernetes as well, right? Before that, though, just one more concept is pod, along with all its containers, runs on one specific node. So what is possible is pod with all its container would be attached to one node. Pod is what gets scheduled. So pod is attached to a node. So all its containers would run on the same node. The reason why pod was created for the co-location. to solve that problem, to ensure that you have whatever needs to be run together runs on the same host, right? If you create another instance of Mongo, maybe that may run on a different node, but along with its own sidecar, that is an exporter. What is not possible is you cannot have a pod with container running on one container running on node A and another running on node B. That's not possible. So that's what I wanted to make very, very clear. So this is why pods were created. Now off to the AKMS formula. AKMS, you've seen this. I'm pretty sure if you have started with Kubernetes, and that is the API version, kind, and metadata and spec. You can remember this acronym AKMS any which way. And you can look at any object in Kubernetes, right? It has that AKMS part. For example, I have this deployment, and if I describe or use get deployment and show you the deployment in the YAML format, you're going to see the same, structure, the API version, kind, metadata, and the spec part. So if you can break down, so this may look too daunting for you initially, but you can easily break it down into these 4 parts. There is another thing called a status, but we don't have to bother about it because status is written by the cluster. We have no control whatsoever about the status, so we don't bother about it while writing the spec. That is, by creating the object. So any object that you create is an API object. We're talking to the API server. API server exposes all these objects in the API format. And the good part about that is everything is programmable. Not just pods and deployments and application components like deployments and services and replica sets and this and that. It is also about the operational components. Like even if you're an operator, that's why even if you're an operator, you must know how to write the YAML spec. So writing YAML spec and ability to read the YAML reference and converting into YAML is the most significant skill that you should take from these sessions, basically. I'm going to show you how to write this YAML spec from ground up with this session itself. And you can actually check what all are the API resources by running kubectl API-resources. So you see, everything in Kubernetes is an API resource, not just the components such as pods and services, even the secrets and configurations in the config map format, volumes and volume related configurations, and the deployments and daemon sets and stateful set. Everything is an API object, and not just the application deployment parts, also the operational part. For example, ingresses, network policies, the authorization in the form of roles and role bindings and whatnot. Everything is a API resource, even the quotas, right? So you define a quota as an administrator, you define some limits as an administrator. So everything is in the YAML format, right? So it's important to know how to write that spec. This is this basically, comes to API version, kind, metadata, and spec, AKMS part. The API version is the API version of that object or the resource in your specific version of Kubernetes. And you can find it from here. So daemon set is at V1. Most of these are at version 1, or some are version 2. Auto scaling is version 2, but almost everything else is almost V1. Some of those are beta. So some features, like for example, flow schemas, are beta in the current version of Kubernetes. So it is being developed right now. Earlier, this was in beta. Some of these like deployments were in beta at some point of time. It started with alpha and then beta and so on. So you basically would find out based on what is supported, what features are supported, are all going to boil down to this API version. So API version in the specific version of Kubernetes that you're using. In this case, I'm using Kubernetes version 1. The latest version, which is 1.25. And that's what you see here. I can also get the short format. Yeah, this will become the norm in future, right? So this will become a default from the next version of Kubernetes. Right now it shows something like this. You can also get a YAML format of API version. Yeah, and I can see it's a 1.25 version of Kubernetes that I'm using right now. right? So API version, kind is the actual object, like pod and deployment and service. And you can find the kind. So there are a couple of places I recommend you look at when you're writing the YAML spec. One is Kubernetes API reference, very important document. And if you search for Kubernetes API reference, you get to this page. And from here, you can pick that specific version of Kubernetes that you're using, like 1.25 that I just showed you. And this API reference tells me exactly what is supported in this version of Kubernetes. Let's say for pod, when I'm writing a pod spec, what are the specifications that I can use? What are the properties that I can add to the pod, right? And that is the one of the next parts after metadata. Metadata is important in Kubernetes. Metadata contains, when you're creating a pod, with what name should it be created? That's the name, metadata name. Labels are useful to filter your pods because I may have hundreds and hundreds of pods. How do I find the specific set of pods from those list is my filtration criteria, the filtering criteria, and that's part of the selectors that we use later. But for all of that to work, for your, for your high availability feature, for your service discovery, for your scalability, all of those features are dependent on the metadata, specifically the labels. So that's another important part of the metadata. And then the spec contains the properties of the kind, like you're writing a pod spec. So this contains the properties of the pod. This is how you write the AKMS, the API, API version, kind, metadata, and spec part. Now I'm going to demonstrate to you by creating a pod spec, and that's going to be your challenge number one. So your challenge number one, let's say, is for you to set up Kubernetes cluster. Challenge number two is when you have to create a pod spec for a specific application. The problem statement would be given to you, and it's basically creating a pod such as this. So you have to create a pod whose name should be vote. It's basically for one of these applications that form the part of this particular stack, the InstaVote application stack, right? And let's say I'm creating a pod for this vote application, the front-end vote application, which is a Python application. The details of those would be given to you, like in this format. So you're creating a pod whose name should be this, whose label should be this. So everything is given. You just have to convert it into YAML. That's exactly what I'm going to demonstrate how. I would also switch my workspace to this directory. If you follow my guide on setting up the Kubernetes environment with kind, one of the steps here lets you clone this repository. Okay, this is what I typically use in my trainings as well, KTS code. That is where I'm right now. In KTS code pods, you'll find some scaffold. I'm writing that vote-pod. So I start writing that from here. Okay. The API version is, how do I find that? Is one place I can look up, of course, is here and find the API version, let's say for the pod. We zoom in, yeah, version 1. There's another place you can find this from, and that is kubectl explain. So you can make it as a conversation. You can use kubectl to talk to Kubernetes environment, and you can ask Kubernetes to explain the pod spec for you. So you can say pod spec or just pod, and it shows you everything like kind and version and the spec here. Let's say you just want to find this particular spec or everything in the spec, you can do so here, or a particular spec called as containers, because pod is made up of containers mainly. And what are the container spec? You want to find that, you can use this as well. And then you can say, oh, I want to find the ports definition for the container and so on. So you get that documentation. So you can start with this explain process as well and get the details of what to write in the pod spec, etc. So I'm writing this document or pod spec with this problem statement. You would be given the problem statement. You just have to write the pod spec and create that pod. So I have to create a pod with name vote. My API version is V1. Yeah. For everything else, which is not part of a core API, like original APIs, you typically have something like apps V1 and something. Pods, just V1. Kind is already given, pod with P, capital. Metadata contains, so this is YAML. You have to be careful with the indentation. So it is part of the metadata. Metadata has name and whatnot. So let me show you that. So this is the metadata for the pod. Metadata is common for all the objects anyways. And it contains many things, but out of those, you will get this with experience that 4 most common things are name, namespaces, labels, and annotations. Out of that, we are talking about name and labels right now, and that's part of our problem statement. So we'll just stick to a problem statement. We have to create a pod with this name and these labels. Labels are extremely important. So name and labels. Name is a string. Labels is an object. You can see the data type here. Name is a string, label is object. Object is basically key value pairs. So I can add key and value pairs to this object and multiples of those. Name is a string. So I just add a name this way. What is the value? I have name is vote. Labels, I have to add a few labels here, not the key value. These are placeholders. But actual labels are these. So I have 3 labels: app, role, and version. This can be anything. You can add as many as you want. The more the labels you have, finer grained control you have on filtering those set of pods. Right. So and then I say, okay, the role should be vote, the version should be whatever the version that we is defined here, v1. And you can add as many as you want. Let's say I just add insta vote as a project. I can add, the org being something. So the more the number of labels, again, I have more control over how I filter it with however many properties I want. And finally, the spec part. Spec contains what? For pods, it's mainly, it has to run container and with this name and this image. And you can also follow from here. A pod contains many properties, right? But we'll just stick to or focus on containers. Containers is an array. Start with this. It's properties of the subproperty of specs. I have to add it with the indentation. Containers is an array. If it is an array, you go to the next line and start with an hyphen here or here, 2-space indentation. Don't use tab. Never use a tab. Tab will not only not work, it will throw some errors which are difficult to debug a lot of times. And container array, each of that item can have, each of the item in an array is a container. So each container can have its own image, name, environment, and I'm just adding 2 properties, essential ones. The essential being the name. But we've been getting the values. So you have to create a name app container with this name and with this image. That is what I'm creating here. Right. So creating a pod with the labels, with the container spec here, and then I save it. This becomes my pod spec. This is essentially the spec created for this pod. The naming of the file, the convention that I use is the application name hyphen the object name, would hyphen pod in this case. And this is a working pod spec, aka AKMS, API version kind, metadata, and spec. What is my metadata? I have this port as a name, and these are the labels. It's going to create a pod with 1 container only. This is the 1 container specification. If I have to create multiple containers, I can add more things like this, and this becomes my sidecar with an image.
Will this work if you don't add that hyphen before the name? Just
No.
the tab?
No, it wouldn't, because it really depends on the containers is an array. So array is starts with a hyphen. So you must add a hyphen. Without the hyphen, it wouldn't work. Wherever you see an array, it has to have an hyphen. That's the YAML syntax. Okay, let me save this. This is how you apply things in Kubernetes. -pod. I'm just doing a dry run. This majorly does the syntax check, that's it. Right, so let's, when it says created with dry run, it's not creating, it's just doing a syntax check. Let's break the syntax, let's remove the hyphen. See what happens. Yeah, I have to use a server side. There are a couple of different types of dry runs. It finds the issue here. So it's not able to find that what is expecting. So pod cannot be handled as a pod, unmarshal object to undergo construct. So this basically is referencing the container spec. Container spec it's pointing to. So approximately, even if you don't know the exact error, it tells you that this error is here precisely. So based on that, you can figure this. So I have 2 spaces and contain. That's the indentation I would follow. This is fine. So what I'm going to do here is split the screen, connect to the same server, and show you what's going on by watching for the pods. Yep. I'm going to create the pod now. I will also be watching for this window right here. Let's see if we can bring this on the site. Okay. All right, that should be sufficient. So you watch what happens on the bottom. You get create a pod will be added. You see what's on the left, and here we go. So pod is created. You see it's in a container creating state. You have a yellow blinking light box here. So the scheduler, we submitted the job to the API server. It went to the scheduler. Scheduler decided it should run on second node. And then it started pulling the image and launching it. And that's the process. During the process, the container creating, and so it was trying to, pull the image and do everything basically. And it's now running. So it's running on this particular node. And I can see that here from here. I can list the pods. I see the pod here. If I want to get more information, I can also use get pods -o wide. I typically use it to find out which node it's running on. So it tells me that it's running on this particular node. Let me make this into full screen. So I already see it's running on this particular node. And I can get more information about it as well. And then I can also use some more options like get pods, -- show labels. This is very important. Tells me that these are the labels which it has. I can also use get pods -a to list all the pods, just to show you how I can filter it. So I have these many pods. I want to find only one pod or specific pod with role vote with version 1. I can do so with a query like this. And it's not just about version V1, it should be. It's not just about us running these kind of queries. It's also the system, Kubernetes, which will be watching for the pods, for the availability, etc. So the high availability, service discovery, load balancing, all of that depends on the labels and the filters that we use, such as this. Right? So very, very important. And that's why metadata is very important. Right? That's what I wanted to show you here. And show labels, filters, -o wide are some common options that I would use with the pods. You can also use describe with pod, with anything basically. And I can describe the pod. Pod as vote, tells me everything about it, like which host it is running on, which node it is running on, what is the name, namespace we'll look at later, which node it is running on, what is the IP address of the pod itself, the node, how many containers it is running, which container has running with which image, And very important is set of events, because this tells you what's going on with the pods and who was involved, right? So again, as I told you, Docker has no role to play, or Kubernetes doesn't care about who's running it, Docker, Cryo, Containerd, or anyone else, right? Because as far as Kubernetes is concerned, we submitted the configuration using kubectl. It went to the API server. From there, the scheduler picked it up. So scheduler says successfully assigned this to this particular node. So scheduling has happened here. And then everything else, if you observe, is reported by kubelet. So kubelet is the one which says, oh, I'm pulling the image. Image has been pulled. This container is created and then started. And kubelet in turn will talk to the runtime and get the job done. Delegate it to the runtime, but kubelet is the one which is reporting. It does the health check. So everything else is reported by kubelet, basically. That's why Kubernetes cares about kubelet, not the actual runtime. That's the point I wanted to make here. Now, let's, this is a pod, right? So I just showed you here. I want to create another pod for database. This time it's a database pod. It's part of the same application stack, but this is the database, is a Postgres database, right? And then what I want to also show you is how the volumes work. So data persistence, for example. So this is a Postgres pod, has one container, DB it is named, and it has to have a volume, right? It's a database. So how are we giving volumes here is, and what you can do with pods is basically you can have one or more containers. So in that scenario, the volume can also be shared. So just like common namespaces like network and host name and so on, you can also create volumes which are given to the pod. Again, I'll repeat that. Volume is given to the pod. That's why it is part of the pod spec. It's a volume called as DB data. And then that can be mounted onto the container explicitly and specifically. So you can mount it on just one container explicitly, and you can mount it like specifically on one container, and you have to explicitly do that using volume mounts. And here you say, oh, this is the volume. I want to mount it on this particular path, volume PostgreSQL data. So that's how you provide the data persistence. There could be different types of volumes, and there's a whole concept of persistent volume claim and storage classes and all that. We'll explore that at some point of time, but I just wanted to give you a brief about how the storage would work. And I'm going to create this, or try to create this pod and see what happens. And this is where I'm going to explain to you the troubleshooting concepts related to pods mainly. Because it's not going to launch. You see that yellow blinking light box, and it's turned to red blinking, which means there's a problem. What is the problem? How do we figure that out? Is what I want to explain to you. Give me one quick moment here. Because there's very specific events which it goes through. Yes, so here. And you will see some symptoms, but the root cause will be something else, right? Now, what is the symptom here? The symptom we see is it's crashing. It is in the crash loop back off. When does that happen? Let's understand the process, how the pod is get created, right? So if you look at the events as well, so I'll show you the events here by describing the pod whose name is DB. So scheduler came in and it said this pod was assigned to this particular node. So scheduling is done here, right? After the scheduling is done, only then it tries to pull the image. And this is when it pulls the image. And this is when you might see, if there's an issue, you'll see a message or symptom related to images. If there's an issue here with the scheduling, you will see the pod typically going in a pending state. Let me show you that. So there are three different stages at which three different types of issues can happen, right? So one is the pending, which is the scheduling part. Second is after the scheduling is done, if there's a problem with the image, it has a different issue or throws a different error. And when the image has been pulled, but it starts crashing, the application has a problem. At that time, you see this crash loop back off kind of an issue. Let me show you all three types of issues here. First, I will create an issue where the pod will be in a pending state. Scheduling problem. I'm simulating a scheduling problem. Trying to recreate the pod with a different configuration, and now you see the pod in a pending state. So why I'm telling you all this is because these are the common issues. And when you see a pending pod, you typically would want to, this is the basically symptom. The root cause you will find by describing the pod. When you describe the pod, you will typically see it's a scheduling problem. Yeah, scheduler says failed scheduling. And what this also means is you don't have to bother about, you can eliminate the issues with the images. You can eliminate the issues with the application at this point of time. Because if it says pending, most likely it has a configuration which is not supported, meaning in terms of, in this case, I'm asking for too many resources which are not available in the cluster, or it could be a dependency it is waiting for. In this case, it clearly tells me that this pod cannot be scheduled, right? Insufficient CPU. Right, I'm asking for too much CPU, and that's why the scheduler says I cannot schedule this pod at this point of time. Scheduler is not giving up though; it will keep on trying to reschedule it at a regular interval. So if I update the configuration and remove that constraint, it would work. But this time I want to create a different issue. Now I wouldn't have a scheduling problem, but I will have a different issue. Let's see what. Now I'm recreating. It doesn't say pending, so which means there is no problem with the scheduling. You can say the scheduler has successfully scheduled. And then while pulling the image, which is the next step, it has a problem. And it clearly tells me that this image is not found. And that's when it has that error image pullback, and it goes in an image pullback off issue. So when you see this issue, what you can safely say is scheduling has happened successfully. No problem. It has not gone to the level where it started the container, so we don't have to bother about the application issues yet. It is purely related to images. Maybe image is wrong, image is not present. There's a problem pulling the image, maybe credentials are missing, and for private registry, for example, and those could be the issues. And I can clearly figure this out by just trying to pull this image as a whole, the one which has a problem. And if I just do Docker image pull, I'm going to get the same error. Tells me unknown manifest, meaning it's not present, not found, right? So that's the problem here. And I know the problems, I can go back and fix it. And in this case, this works. If I create it now, it does work. And it's gone ahead, scheduled, pulled the image, started it, right? Scheduling has happened, image has been pulled, container created and started. Now comes the last part here, crash loop backup. Because when I describe this, it has none of the issues that I showed you just now. This is the third type of a problem where container is not, it's scheduled, image is pulled successfully, container was created and started. Now the issue happens after starting the container, which means there is typically a problem with the application. Application is crashing. How do you figure this out now? Is you try to check the logs. I started with describe, of course, but I will have to check the logs to find out the issue. If I don't see it in the logs, I'll have to launch it manually with, let's say, Docker run -idt, whatever, and see what happens then. Because if it is crashing, it will also crash when you launch it manually. In this case, though, the good news is when you say kubectl logs and db, I'm going to see the problem. And there's the same problem that was mentioned by Anthony earlier when writing Docker Compose. Even with Docker Compose, you would have seen the same problem. Basically, this image doesn't work, or you can't launch a container with this just like this, because it requires you to provide either a password or say that, oh, I don't need a password. So either of this environment variable needs to be set. So how do you fix it? Is by adding an environment variable to what? To this pod spec. It's already there. Even if you try to do it yourself later, you will have access to this repository. So you'll have this code. You just have to add an environment variable. Let's find out where to add it. Now, I'm writing a pod. So maybe I'll start with the pod spec. That might be the obvious thing you may do. Let's see if it is part of the pod spec, if we can find it. I'm going back to the API reference document, looking at the pod. Pod has spec. Specs are alphabetically ordered. So environment variable starts with E. I don't see it here between D and H. So definitely it's not part of the pod spec. So next thing that comes to my mind is containers, and containers is obvious because applications are ultimately run with containers. Containers have the environment. So if I go to the container spec and look up here, I have a couple of different options here, env and env from. In this case, I'm just going to add an env, which is an array. And here I can add the name and value. Name and value is the environment name, variable name, and its value. How do I add it though? And where? This is the container spec. So I would have to go to the container spec. It's part of the container spec, which means this block limited to this part. And anywhere here, I'll just go here and add the env. Right here. And it's an array. That's the most important part. Again, don't miss that. Array means hyphen. And I just have one environment variable with name and value, value from. I don't have to bother about it right now. So I just add name and its value. What should be the name of the environment variable? I already know it from here. So I copy from here, add it, and the value being trust. Yeah, this is set to trust. That is the value. This is how I add it. Now, if I try to apply this way, after making this change, you will notice that it doesn't work. An obvious thing when you see a message like this is to look up what's going on here, but the problem is not here. Problem is here, forbidden. When you see forbidden, it means it's immutable. This field is immutable, meaning pod deployments in Kubernetes are typically immutable except for certain properties like image and so on. So what you have to do here is, since it is immutable, you have to delete it, delete pod, or even delete -f. Delete -f does not delete the file, it just deletes the object created with the file. And then apply again. I have already added the configuration, so dp-pod should work now. And it does. And this is how you typically troubleshoot the issues, right? So that's how you troubleshoot the issues with the pod. And three typical types of issues. The symptoms, three typical symptoms you'll find are either the pod is in pending state, it has an image pullback off, or it has a crash loop back off. Those are the three common issues that you would find with the pods, basically. And this is how you typically troubleshoot, because if it is pending, scheduling problem, most likely. Image pullback off, image issue, crash loop back off, and application issue. So when you see crash loop back off, you can easily eliminate scheduling and image related issues. All of that has successfully happened. It's only after that it is failing. So it is important to know the stages and where it is failing based on the error that you see here. That's what I want to demonstrate to you. And finally, I'll just show you how you can create a pod with more than one container. How does it look like? So I have a pod here with two containers. The name of the pod is called as web. It has two containers, Nginx and sync. So you see, it's an array. That's why containers is an array. And this is the first item in the array, starting with this hyphen. The second item starts here. And what do you have here? It has image, it has the name, of course, and volume. Even the volume is same, but it is being mounted at two different locations. Same data, same volume, but being mounted specifically, explicitly in each of this container. I could just mount it in one container, but I just wanted to show you, demonstrate both the containers and how it looks like. So let's see how this would look like. Let me start watching for the pods first. And then I will apply the multi-container pod, and you are going to see started creating the container. You're going to see it here as well in the visualizer. Launched here. You see also a division here. This division represents a pod with multiple containers, basically, in this case, 2 containers. Still container creating because it's pulling the images for both of those containers, and it's now in a running state. I can also examine it here by using describe pod, and describe tells me everything about it. Like you can see it has pulled this image and this image. It also tells me that it has this volume colors data, which is being mounted at 2 different locations here and here. There are 2 different containers. So containers now, there's one called as Nginx, there's another called as sync. And now, how do we manage it, right? Because now if we have to exec, kubectl exec, which one would it go in? Let's find out. There's some default behavior. Also for the logs. So if I want to check the logs for the pod whose name is web, we typically do it this way. But in this case, it only shows me Nginx, right? Because that's the default. The first one is the default. If I want to check the logs for the second one, I have to use -c, and sync. Sync is the name of the second container. Yeah. I can also use it explicitly rather than defaulting to something as this. And again, I can also do logs -f to follow the logs. And this is syncing or updating from Git every 10 seconds. That's part of that code as part of the container. And you see that happen. So you can follow the logs as well. Similarly, you can use exec. There's only slight difference between Docker exec and this. This is similar to Docker exec, Docker logs. And the only book's reference is the command comes afterwards. So Nginx this way, sync this way, exec-it to interact. Exec-it and interact. Yeah, you can see it has its own process. PID is separate, processes are different. That's isolated. The images are different, of course. This is running with Alpine. This one has its own. These are 2 different containers which are part of the same pod. Basically, what I'm showing you is something like what I showed you earlier here. Yeah, there's Nginx and there is sync. This is Alpine, this is Ubuntu or something like that. So there are different processes, different images, but the network wise it's same. The same IP address, same host name. So there are common namespaces. So host name is given to the pod, not to the container. The IP address is given to the pod, not to the container. And then in this case, the volume is mounted, same volume, but mounted at 2 different paths. Inside Nginx, it is this path. On the second container sync, the same volume is mounted at var app. So here it is this path. Here it is this path, right? Essentially the same set of files. Because if I touch from here, it's available here. If I make changes from here, those are reflected here. Basically, we're sharing the files. So you can use a volume which is then shared but across the containers and mounted at 2 different locations, that is. So you can see it's different location, different path into different containers. Same volume can be mounted at 2 different paths as well. That's how pods with multiple containers look like. and this is how you can explore. So the only difference here is you add -c than how you explore the rest of the pods. And that sort of brings us to the end of today's session that I wanted to talk about. Basically, how do you create pods? How do you deploy those? How do you explore multiple containers in a pod? And your challenges, I think I'm going to share 3 challenges with you. One is to create the Kubernetes environment with kind. You can use any other approach, use kubeadm or anything else as well. That's number 1 challenge for you. Number 2 challenge would be to create the pod for the same application, the board application. You'd be given the details here. Number 3 would be to add resource separation to this. So there'll be another challenge for you to explore on, and to explore mainly the spec here, and to add the resources definition. So CPU and memory, and I'll give you minimum and maximum of that. And you have to create that concept and add to this. Okay, I'm just gonna mute everyone unless there are any questions. So are there any questions? If you have any questions, you can, unmute yourself one at a time and ask. Okay, I've put everyone on the mute. So if you are asking question, make sure you're on, you have unmuted yourself. If you're on the streaming channels, you can also post the questions from there.
Yeah, I just want to ask about the installation of Kubernetes.
Sure.
So basically, you said that the kubeadm is used in production, right, to install mostly. And I just want to know what is the difference, or what is widely used, or what are the advantages of kubeadm compared to the managed Kubernetes like EKS and AK, Azure and AWS Kubernetes services.
So basically, with managed environment, you get almost everything ready. Especially with GKE, for example, Google Kubernetes Engine, it's this is the simplest. It's very easy to set up and click, and you have a cluster ready. EKS takes a little more amount of steps, but basically the environment is managed in terms of control plane, and setting up the control plane itself is automatically be done. Secondly, the management of control plane, because if you're setting it yourself, you have to monitor, you have to watch, you have to make sure it is all running, and it's all available and so on. So in case of managed environment, it is all taken care by the managed service. Number 3 is the networking part. When you set up with kubeadm, there are explicit steps. You have to initialize the master control plane, you have to join the nodes, then you have to generate the tokens in for future nodes. You have to, if there's upgrade, you have to do it yourself, right? So that's a whole process of doing that. Networking, you have to set up yourself because Kubernetes does not come with the networking by itself. You have to choose a CNI plugin. In case of managed environment, they have their own version of it, and it is all set up automatically and done for you. Whereas with kubeadm or similar approaches, you have to do this step-by-step process. Plus, you have to manage that environment, mainly the control plane environment. Scale it, manage it, back it up, upgrade the nodes. So all of that is something you have to do, versus in a managed environment, like a lot of those things are done by the managed services.
So even COPS is used, right, in production, like yes. Instead of kubeadm, is it?
COPS is a good tool when you want to deploy stuff on cloud. kubeadm works everywhere. But COPS is like mostly, so COPS was created initially when there was no managed EKS and AKS, AKS for Azure, EKS for EC2. Both those clouds had their own container orchestration services like ECS, and Azure has Azure Container Service and so on. But then community, even at that point of time, AWS was the number 1 platform of widest amount of, or largest number of Kubernetes installations were there. So people needed some tool to deploy Kubernetes on these cloud platforms. And then that's when COPS was born, KOPS, that is. COPS is a very interesting tool, and you can use it to launch Kubernetes on the cloud. It does a lot of setup and takes care of that as well. So you can very much use that. You can also use services like Rancher. Rancher is another useful utility to deploy Kubernetes nodes and environment on different clouds, manage multiple cloud. You get a single pane of glass to manage all your clusters and so on. So you can use these tools to do that as well. Rancher being a very interesting tool as well. So you can pick KOPS, KOPS. You can use Rancher. You can use KubeADM to do it yourself. If you want to learn, I would definitely recommend you try to do it with KubeADM at least once. Gives you a little more detailed idea. And even if you want to do even harder way, there is a tutorial called as Kubernetes the Hard Way, which is like installing everything by yourself by Kelsey Hightower, a very famous and prominent personality in the world of Kubernetes. He is. And he has created this Kubernetes the Hard Way. I don't know how relevant it is today, but if you want to learn a lot about Kubernetes, this is your option. Kubernetes the Hard Way. The hardest part of the spectrum, somewhere in the midway, stands KubeADM, and then KOPS and Rancher start making it easier and easier. And the easiest way is to go and use a managed service. After managed service, I would say Kind is the next one, which is simpler. Yeah. All right, there's another question on the chat by Raven about Kubernetes objects and resources are the ones and same. Yeah, so Kubernetes objects are mainly the resources, basically. So this is the resources that you manage. The more relevant word is resources. So when you say pods, deployments, services, replication controllers, daemon sets, network policies, quotas, persistent volumes, all of these are Kubernetes resources. And you can list them using Kubernetes API resources as a command. Right, I've shown you already. So you can list them using Cuttle API resources. All the components that you can manage with Kubernetes are listed here with KubeADM, kubectl API -resources. That's what you're going to get started with. Kubectl explain and Kubernetes API reference are essential references that you must use. Another question from Dinesh is, what about OpenShift? OpenShift is more like a PaaS, a platform as a service on top of Kubernetes. So if you want to look at Kubernetes, you can think of it as a container as a service platform. Kubernetes is, right? So you take, basically, you need to have a knowledge of how do you deploy the containers at scale using deployment services. How do you connect them? How do you set up the load balancing? How do you set up ingress controllers? How do you set up persistent volumes and storage and so on? So you need to have that knowledge when you're trying to use Kubernetes directly. With OpenShift, it abstracts it away and it makes it easier and easier. You can still use it as an underlying technology that is Kubernetes and comes with it. But on top of that, OpenShift also brings all the components together and it converts it into a PaaS platform. So with OpenShift, what you can also do in the simplest format is you're a developer. You don't even know about anything about Docker or Kubernetes, forget about everything else. You just have a code repository. You can point to that and OpenShift will fetch your code, automatically detect the language, convert it into an image by writing the Docker file automatically and the logic behind that. There's a module for with OpenShift which comes with that for certain languages, of course, and it will take your code, convert it into an image, put it into registry. So OpenShift also has a built-in registry, and then also deploy that. So it will write the deployment similar to deployment. They have a deployment spec. There's something else. They have a different name for it. So it starts with deployment, but it has a certain variation of it. So it will write a deployment, it will create a service, so it will create everything on its own, and it would have everything deployed. So that is what OpenShift is capable of. Do people use it that way? Not a lot. A lot of organizations pick OpenShift just because it's a Red Hat supported product. So you basically get the enterprise version. You get support, paid support, right? Because a lot of companies have this liability and legal compliance and stuff like that they have to take care of. So they need a vendor to grab hold of in case there are issues and they need paid support and all that. For that reason, a lot of companies I know use OpenShift, but they don't use it as a PaaS solution. They still rely on writing the code by themselves and they treat it as a Kubernetes environment, but they choose OpenShift just for the sake of that compliance part and legalities. But that's what OpenShift is. OpenShift is pretty cool, but it's a nightmare to set up, in my opinion. Earlier, they had a mini shift environment like mini kube, but now I'm not sure recently, but when I wanted to revamp my course, which I had authored initially, it was a nightmare to set up. It just takes too many resources, but Kubernetes right away. And if you want to learn, definitely pick up Kubernetes over OpenShift. But OpenShift is still an interesting solution if you're looking for a PaaS abilities, I would say. All right. Any other questions, folks? All right. I'm just going to check the things from the sheet. Okay. All right, I think we're done then. We're also almost out of time. So you have access to the challenge by tomorrow. I'm going to upload that and you can get started with it. And the next week, we'll come back with the next part. We're going to make this application high available and scalable. That's going to be the next mission for you. So do complete this mission where you would be creating the pods. You would be setting up the Kubernetes environment. You would be creating the pods. You'd be writing or getting started with the YAML spec. And you'd be doing a little bit of troubleshooting as well, and a bit of spec writing part as well. So that's what you have for this week. You will have access to the challenge again by tomorrow. And I wish you all the best to complete this mission. And I'll see you in the next mission on next Thursday, where we get started with namespaces and replication control. Right.
Thank you, Gaurav. I appreciate. Bye.
Yes, Anthony, go ahead. Bye. All right. That's that then. Bye-bye.
Thank you. Bye.
Thank you. Good to see you, Peter. Yep. Bye-bye.